Hi, in this video we'll be talking about recursive generators. If you haven't watched my previous videos on generators, it's definitely recommended to do it before you go on with this video. I also have a video on recursive functions, so feel free to watch it too if you're not sure what recursion is all about. Now, just like regular functions, generators may be recursive, which means they can call themselves inside their function body. A good example to demonstrate it is a generator that creates all the permutations of the letters of a string. A permutation is a rearrangement of all the elements of an ordered sequence. So the sequence AB has just two permutations, AB and BA. The sequence ABC has 6 permutations, ABC, ACB, BAC, BCA, CAB, CBA. The longer the sequence, the more permutations there are. We can calculate the exact number of permutations of a sequence by finding its factorial. So if we have 2 elements in a sequence, there are 2 factorial, which equals 1 times 2, which equals 2 permutations, as shown above. If we have 3 elements, the number of permutations is equal to 3 factorial, which is 6. If we had a sequence consisting of 5 elements, there would be 5 factorial permutations, which is 120. Generally, a sequence of n elements has n factorial permutations. Although Python is rich in modules that make mathematical stuff easier to handle, and naturally there is a module where a special function to create permutation exists, the itertools module, this section is about recursive generators, so we'll choose the harder path. So let's write the code that will print all the permutations of the letters of a word using recursion. Here's our function. Def permutation generator. Here's our word for which we want to find all the permutations of the letters making up this word. Now, if len of word equals 0, so if the word is an empty string, yield an empty string. Fine. There is no word actually, so there are no permutations. And in any other case, so if the word consists of at least one letter, let's use the following code. Else for m in range len word. So actually for each letter in the word, do the following. For n in, and here we're using the generator recursively. Permutation generator word sliced from the beginning to m plus word sliced from m plus 1 to the end. Yield word m plus n. So this code yields one letter and recursively finds the permutations of all the remaining letters, adding them to the first letter. Then the same is repeated for each letter until all combinations are found. Now let's write the following for loop. For x in permutation generator, and let's use the word home. Print x. Fine. Let's run it. And here is the output. Home, home, HMOE, HMAO, HAOM, and so on. Here we have all the permutations. Now, to visualize the first couple of examples, here's how it works. First, we have H plus all the permutations of the rest of ohm. But ohm gives us O plus all the permutations of MA, which are MA and AM. After we get all the permutations where H is the first letter, we find all the permutations where O is the first letter. So O plus all the permutations of HMA, and so on. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.